Today we're going to talk about the blue sheet that I gave you in class today. I made this sheet blue because it's really an important part of your Chapter 9 notes that you have to be aware of. There are two special right triangles. Hopefully you remember them, learning about them in geometry class. But there's one special right triangle called the 45-45-90. And what that means is that the two angles that are not the right angles are 45 degrees, and then this one angle is 90 degrees in the corner because it's a right triangle. The 30-60-90 is the second one, and here's the 90-degree angle in the corner. Here's your 30-degree angle, the smallest one, and here's your next biggest one, 60 degrees. And what we're going to do is we're going to find all 6 trig functions of 45 degrees, of 30 degrees, and of 60 degrees. In a special right triangle, please, please never, 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 never use a calculator to find these trig values. These trig values being sine, cosine, and tangent, and then the reciprocals. What you're always going to use is you're always going to use these pictures or these diagrams of what the length of these sides are. In a 45-45-90, because these two angles are equal to each other, their sides are also equal to each other. So what we usually do is we call them a length of 1. Maybe this is 1 centimeter, maybe it's 1 inch. But in any case, these two sides are equal because this is actually an isosceles triangle, so these two angles are equal to each other. And if you use a squared plus b squared equals c squared, 1 squared plus 1 squared is equal to c squared, which is 2. So the hypotenuse of a 45-45-90 is the square root of 2. So if you can remember that it doesn't matter if these are 1 and 1 or 2 and 2, but these two are equal to each other, and then this is the square root of 2 times whatever this length is. So what we're going to do on this 45-45-90 is, again, we're going to do SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And it doesn't matter which angle we choose. We can choose this one because they're both 45s. So here's the 45-degree angle, and here's the opposite side, here's the adjacent side, and here's the hypotenuse. And if you do SOHCAHTOA on this angle, 45 degrees, opposite over hypotenuse is 1 over the square root of 2. But we don't, in a 45-degree angle, we don't leave it like that. What we're going to do is rationalize the denominator like we have before. But before we rationalize it, let's just flip him upside down so we can get the cosecant of 45, which is the square root of 2 over 1, which is just the square root of 2. So the cosecant is easy. You don't have to rationalize the denominator. But the sine of 45, if you rationalize the denominator, multiply by the square root of 2 over the square root of 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is just 2. So the sine of 45 is the square root of 2 over 2. This is something that you need to try to remember quickly, or if you could draw the diagram quickly, because these numbers come up all the time. Excuse me, all the time. Well, the cosine of 45 is adjacent over hypotenuse. It's the same exact thing. 1 over the square root of 2. The secant is the same exact thing, the square root of 2 over 1. And if you rationalize this denominator, you get the square root of 2 over 2. So the sine of 45 equals the cosine of 45, which both equal the square root of 2 over 2. Well, the tangent of 45 is opposite over adjacent, 1 over 1, and 1 over 1 equals 1. The cotangent is also equal to 1. So there are your 6 trig functions for 45 degrees. In a 30-60-90, the smallest side by tradition, we call the smallest side equal to 1. And in a 30-60-90 degree angle, triangle, the smallest side is 1, the largest side, which is the hypotenuse, is always twice that. If this is 2, this is 4. If this is 10, this is 20. So no matter what, the smallest side is half of the longest side. And the longest side, remember, is always the hypotenuse. Well, if you do a squared plus b squared equals c squared, 1 plus b squared equals 4. So b squared is equal to 3. So b is equal to the square root of 3. So this side over here, opposite the 60-degree angle, is square root of 3. A lot of people get these two sides mixed up, so just be careful because the square root of 3 is really less than 2. And you know the hypotenuse is always the longest side, so just try not to mix those two sides up. We're going to do SOHCAHTOA. First of all, if you talk about the 30-degree angle. The 30-degree angle, if we're referencing this one, this over here is the opposite side, and this down here is the adjacent side. And 2 is always the hypotenuse. So SOHCAHTOA, sine is opposite over hypotenuse, which is 1 over 2. And the cosecant is flipped upside down, 2 over 1, which just equals 2. The cosine of 30 is adjacent over hypotenuse, which is the square root of 3 over 2. And you flip that upside down and it becomes 2 over the square root of 3, but usually we rationalize that denominator. So it becomes 2 times the square root of 3 all over 3. Tangent of 30 is opposite over adjacent, so 1 over the square root of 3. Flipped upside down is the square root of 3 over 1. But then when we rationalize this denominator, multiply by the square root of 3 over the square root of 3, we can call the tangent of 30 the square root of 3 over 3. So those are very important numbers that we're going to have to reference all the time throughout the rest of this chapter and the next few chapters. Over here we're talking about 60-degree angle, the 60-degree angle. So now we're not going to be using the 30 degrees as our reference. We're going to be using the 60-degree angle up here as our reference. So now this side down here, instead of being the adjacent, he's the opposite. And this side over here, instead of the opposite, he's going to be the adjacent. And now we're going to do SOHCAHTOA, opposite over hypotenuse. For the sine of 60, the opposite side is the square root of 3, the hypotenuse is 2. Flip that upside down and you get 2 over the square root of 3. And hopefully you remember we did that already over here, 2 over the square root of 3. When you rationalize that denominator, that becomes 2 times the square root of 3, all over 3. The cosine of 60 is adjacent over hypotenuse. Well, the adjacent side is 1, the hypotenuse is 2, and if you flip 1/2 upside down, you get 2 over 1. And the tangent is opposite over adjacent. Well, the opposite side is the square root of 3, and the adjacent is 1, so square root of 3 over 1, we usually just write it as the square root of 3. And if you flip that upside down, you get 1 over the square root of 3. And if you rationalize that denominator like we did back here, you might have noticed that it's the same thing as the tangent of 30, 1 over the square root of 3, and that turns into the square root of 3 over 3. So these are really, really important numbers that, like I said, do not ever use a calculator if you're trying to find the sine, cosine, tangent of a 45-degree angle, a 30, or a 60-degree angle. And you don't need one either for a 90-degree angle. Down here on the bottom, what I've drawn is 3 unit circles. And what I've drawn inside these unit circles are 45-degree angles. Here's a 45-degree angle here. Here's another 45-degree angle over here if you're talking about this angle. These angles are always resting up against the x-axis. This down here is 45 degrees. And this angle down here is 45 degrees. Over here, I've drawn angles that are 30 degrees when they rest up against the x-axis. So here's a 30-degree angle. Here's a 30-degree angle. This one down here is 30 degrees, and this one down here is 30 degrees. And over here, I've drawn 60-degree angles that rest up against this x-axis down here. So here's a 60-degree angle here. Here's a 60-degree angle here. Here's a 60-degree angle here. And here's a 60-degree angle here. And why these angles are important are we're going to talk about all of the multiples of 45 degrees. And we're going to talk about the sine, cosine, and tangent of all of the multiples of 45 degrees. Okay. Now, if you remember, if you have a point P on the unit circle, this point P is equal to the xy value is equal to the cosine of theta comma sine of theta. So this point P, which is xy, is equal to the cosine of not theta now. We have a 45-degree angle that we've actually figured out, or I've told you this is 45 degrees. So this theta really is 45 degrees. And we've already calculated the cosine of 45 degrees up here. It's the square root of 2 over 2, and so is the sine of 45 degrees. So this point on the unit circle actually has coordinates of the square root of 2 over 2, comma, the square root of 2 over 2, because it's the cosine and the sine of our 45-degree angle. If you use symmetry around this unit circle, what you have is another point over here, which are the exact same coordinates as of what you see, except because we're going backwards on the x-axis, the x value is negative, so we have negative square root of 2 over 2, followed by the positive square root of 2 over 2. So this point, we'll call this other point P also. This point P has these coordinates. Because of symmetry again, when we go down into quadrant 3, we're going left and down. So both of these coordinates are going to be negative. So it's negative square root of 2 over 2, negative square root of 2 over 2, the coordinates of this point down here. And then the coordinates of this point, because we're going right, which is a positive x value, square root of 2 over 2, but we're going down, then y value is negative, square root of 2 over 2. So we have these major points on the unit circle when we have 45-degree angles here that rest up against this x-axis. Over here in the second set of triangles, this angle is 30 degrees. So because this angle is 30 degrees, this point, which has coordinates of x, y, the x value is actually the cosine of 30, comma sine of 30. And we've already figured out what the cosine and sine of 30 are up here. So this point right here has coordinates of negative square root of 3 over 2, or I'm sorry, positive square root of 3 over 2, comma positive 1/2, because you're going over and up. So the cosine is square root of 3 over 2, and the sine is 1/2 of a 30-degree angle. Now, because of symmetry, we're going over here in the second quadrant. The x value, or the cosine of the angle, is negative. So this point here has coordinates negative square root of 3 over 2, but the y value is positive because we're going up. Down here in quadrant 3, this point here, both the x and y's are negative, so we have negative square root of 3 over 2 and negative 1/2, the same exact values, except sometimes they'll be negative. And if you go over to the right and down, you've got a positive x value, which is the square root of 3 over 2, but the y value is negative, negative 1/2. So there are the 4 important points in this unit circle. Now we have a 60-degree angle, and this point up here, xy, is actually equal to the cosine of 60 followed by the sine of 60. Well, the cosine of 60 we just figured out up here was 1/2, so this point right here has coordinates of 1/2, And then the sine of 60 is the square root of 3 over 2. And because of the symmetry around this unit circle, these xy values are going to be exactly the same. The only difference is sometimes they're going to go negative depending on what quadrant we're in. So because we go left and up, the x value is negative, so we've got negative 1/2, and then we have positive square root of 3 over 2 for this point. This point down here on the unit circle, both the x's and y's are positive, so it's negative 1/2 and negative square root of 3 over 2. And down here in quadrant 4, the x is positive, but the y is negative. So we have a positive 1/2, but we have a negative square root of 3 over 2. So there are 4 more important points. So we have a total of 4 times 3 is 12 important points that go around the unit circle, besides the other 4 points that I told you about before, which are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. On the back, there's a couple of just a couple pictures of unit circles, and remember the unit circle, the 4 major points, if you're just looking at it like this, are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So if you wanted to know the cosine of 90 degrees, it would be 0. The sine of 90 is 1. The cosine of 180 is negative 1. The sine of 180 is 0. The cosine of 270 degrees is 0, and the cosine of 270 degrees is negative 1. And then either 0 degrees or 360 or 720 or whatever multiple of 360 you want to make it, the cosine of 0 is 1 and the sine of 0 is 0. So those are the 4 major points on that unit circle. And then this is just a summary. This unit circle right here is just a summary of these 4 individual unit circles that I put on here. So what we have here is we have coordinates square root of 3 over 2, because this is our 30-degree angle. We have our 45-degree angle, and then we have our 60-degree angle. So we have the square root of 3 over 2, comma, 1/2. This one being our 45-degree angle, we have the square root of 2 over 2, square root of 2 over 2. And if you want to check back, just to make sure that we're doing these things right, I just put that point on and that point on. And now up here, here's our 60-degree angle. Our 60-degree angle has coordinates 1/2 square root of 3 over 2. Over here, now from symmetry, these 2 points are going to be the same. The only difference is the x is going to be negative. So we have negative 1/2 and positive square root of 3 over 2. Down here, we have negative square root of 2 over 2, positive square root of 2 over 2. And down here, we have negative square root of 3 over 2, positive 1/2. So here's the 3. Here's the 60-degree, the 45-degree, and then the little 30-degree from the other page. And then the same thing here, we've got the 30, the 45, and the 60. So we're going to just copy these coordinates, but this time we're in quadrant 3, they're both negative. Square root of 3 over 2, negative 1/2. That's this point. This next point, negative square root of 2 over 2, negative square root of 2 over 2. And this point down here will be negative 1/2 and negative square root of 3 over 2. Now we have 3 more to go, and we'll be done with this video. Yay! And then because of the symmetry, this one and this one have the same coordinates. The only thing is the y goes negative, so the square root of 3 over 2 is positive and 1/2 is negative. This one, the square root of 2 over 2 is positive, and then the y value is negative. And this point down here, the x value is positive and the y value is negative. So what we have here are all the multiples of 30 degrees, 45 degrees, and 60 degrees all around the unit circle, and these coordinates are very important. Actually, we could probably put the other 4 in here. Here is 1, 0. Up here at the top is 0, 1. Over here on the x-axis on the other side is negative 1 comma 0. And over here is 0 comma negative 1. So what this is going to lead up to is we're going to be able to figure out the cosine and the sine of any multiple of 45 degrees or 30 degrees all around the unit circle. So that's going to be coming up real soon. But if I ever mention the blue sheet, remember that the blue sheet means what are the values of sine, cosine, and tangent of 45 degrees or 30 degrees or 60 degrees. And that's it for today.